Hello everyone and welcome. This is Professor Thayer with you here today to talk to you about the functions. So this is the penultimate lesson in our functions discussions, almost the last one before the last one, penultimate. And we will be talking today about the sticking points. So there's a number of things that we have touched upon in the functions throughout the course of our discussion about the functions, and they've been in your readings. But I know they always cause some confusion and trouble. So I want to just take one of our lectures to just talk about those sticky points. What are the things that make people stumble, that cause problems when you're trying to do the functions, that cause things to not work when you are running your code, writing your code, trying to solve your problems. So let us go ahead and address some of those tonight. And so I need to share my screen. Let me do this. And as always, you're welcome to follow along with us, or you can download them and get them yourself. All right, so those sticky points. Let us be very deliberate about the flow in the functions. So let's talk about this. We've done the function calls already. You've seen them. And what I want to do in this slide here is to compare and contrast two different styles of writing the functions. So here's a very simple linear function that does greeting. Okay, so here we have our comments at the top. Here's my name, name equals Professor Thayer, and we're going to print hello, comma, name. So this is a program you could have written, is very close to hello world, and there's no fancy stuff going on here at all. So I think you can all agree that this will simply just make this output here, hello, Professor Thayer. And so we need to imagine that there is a pointer moving along to point out where the program is at in terms of its processing. Now remember that it's processing one line at a time, sending those down to get turned into the bytecode and to go to the Python machine, and then going into the CPU to actually get processed. And so this is basically that pointer is keeping track of where things are at. So comment, 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 Python doesn't need to do anything. Variable name equals Professor Thayer, fine. And then we print hello, Professor Thayer. So we call this one the linear one because it really does run from top to bottom, and there's no fancy business going on here at all. Then we get to the greet function in this version. We have it in the function, and we see that the matters get a little bit more complicated. Now remember that when we have that pointer, just because you have a function doesn't mean that the function has actually been read in yet. This is one thing that can sometimes be confusing to students, and many times a student will write a script and they'll say, oh, Professor Thayer, look, I have my function right here and it doesn't work. And the first thing I'm going to think of is, well, did you call it? You need to make sure you call your function, because Python will simply just learn how to do a greet, but it doesn't mean it's actually doing a greet until you, in fact, actually make your function call. So the imaginary pointer comes from the top of the script and comes along and says, oh, got to learn how to do a greet. Def greet, all right, greet function. This is what I got to do, print hello in the name and do some returning, okay? And the pointer goes on, but it doesn't actually do the function yet. It says name equals Professor Thayer. Okay, fine, we store another variable. There's the function call. Okay, greet of name. So name gets replaced by Professor Thayer. And now the control proceeds from here back up to the def line. So it's going to go here. And now it's going to do an implicit variable assignment. Name is getting the value of name here. Notice we do have shadowing here because we have the global name and we also have the local name, which so happens to also be an input parameter. So here we're going to have a variable assignment of name, which gets Professor Thayer from this name here. It will print hello, comma, name. And then the return statement will return the control back to the caller, which is the function call right down here. So both of these functions, well, okay, this one's a function, this one's not a function. Both of these programs have the same output. We see that it produces the same thing, but the way that we got there is very different. This one was just linear, and this one had all of this control which is going around that we need to follow in order to get to the result that we got. I also want to talk to you a little bit more about those return statements. Now, the return statements are always a little bit confusing because they're explicit returns and they're implicit returns. And sometimes you return something tangible, if you will, and other times you return something that's not really carrying any information at all. And so it can become very confusing about the return statement. So let's just take a few moments to talk through about the return statement. A return statement aborts the execution of statements within a function body. So even if there is more code after the return, if your pointer gets to that return statement, that's it. It's over. Function execution is terminated. The value of the expression following the keyword return is the thing that's going to be returned to the function's caller. That's how we get the information out of the function, because remember, the function is going to terminate and all of the variables that are the local variables are going to be destroyed. And so if we couldn't send the information out, how would there be any way to capture it? Well, it's because of this return. If return is not followed by an expression, then none is assumed. So if you don't say after the return an expression that you want to return, it's going to assume you don't want to return anything, and so it will return none. If the function body ends without a return statement explicitly, then return none is implied. This will be determined because of the indentation of your Python code. Remember how the body of the function needs to be indented relative to the def line. So when that return, when the indentation stopped being indented, it will assume that the function is over, even if you don't say so explicitly with a return. It's a good idea to put a return statement in your functions, especially when you're just getting started. So then, I like to liken this to these two symbols that I have shown over here. Return statements are kind of like a stop sign and an Amazon box. The stop sign is because the execution of the function will terminate, as we have said. So there's no more function execution, and the function will simply just return back to its caller. And the other thing is this Amazon box. And the big question is, well, what's inside the box? Is there anything useful in there? Did they send me an empty box? Is there something inside? I hope it's good. So we always get a box being sent out. That's what we mean by we always return something. There's always an Amazon box coming out of the function. The question is there something inside? If there's an expression, the value of the expression is what goes inside the box. If there is not anything getting returned, then we still need to put something in there. We need to put the none in there, indicating that the box was processed and there isn't anything inside. And so we have these two kinds of things. Let's just take a look at this in some more detail, because sometimes this can be a little bit confusing, because what we see with our eyes does not always match what we think is in the box. So there's a variety of different kinds of syntaxes that you can see, and I've matched these up to some examples over here of some short little functions to take a look at. So we're going to be now spending particular attention on the returns. So if you have an explicit return, this is the easiest type to recognize, because you'll see, Googling with your googly eyes, you will see actually the word return and then some expression after it. So here's an example of return, have a great day, right? So it's very easy to figure out what's going on here, because we can see the return right here and there's an expression after it. And so this means that the expression after it, which happens to be a string, is what goes in that Amazon box, and that is what gets sent out from the function. Now it gets a little harder. If we have an implicit null expression none, this is what it looks like. It just says return. So your eyes are oogling the word return, but there's no expression after it. And so this is going to be an implicit none. So it will return, and it will return none, which is implicit here. So here's an example of greet 2x. You will print 2 times hi. Now printing is not returning. You might think, oh, it did return something, it returned hi, but it does not, because printing is an effect in the environment. It changes pixels on your screen, but it does not send information to the program. Return is what has the ability to send information to the program. So we have return with nothing after it. This means that nothing, when in the Amazon box, which we're going to symbolize with this null symbol right here, it means return none. Well, what is the type of none? Well, it's none type. So this box is sending back a none. Then we come over here and implicit return and implicit none. This is the most difficult one. And because your eyes are oogling the function, you say, oh, it didn't return anything, Professor Thayer. There's no return here, right? Oh, it's no return, right? Well, that's not true. And the reason is because when you stop indenting, then Python is going to infer that your function has terminated, right? So there's an implicit return here, and because it didn't specify what it should return, it will assume you're returning none. So the type of this function will return none type to go in your signature. So the meaning of this is also return none. So you can have return none either by return with nothing after it, or the termination of the indentation, which has both an implied return and the implied none. So inside the Amazon box, we will also get the none. None and none type. So let's just talk about these two things, and let's try to make sure we understand the difference between none and none type. Now, we've talked about types before, and so if I said, here's a string, what's the type of it? And you'd easily tell me it's str, right? Because it's type string. Well, in Python, there's a type with exactly one value representing the idea of no information. That's when we're not returning anything substantive. We might instead be doing an action in the environment or simply just not returning anything. And so the value is none. And so everything in Python needs to have a type. Well, what's the type of none? Well, there wasn't one. So Mr. Guido van Rossum invented the none type. So the type of none is none type. And so I'm going to use this null symbol to indicate the idea that, yes, there's something, but there's no information. The type is none. Since the none value provides no information, the Python interactive interpreter suppresses printing it, which can be very confusing, especially to people who are just getting started with programming, because you say, oh, Professor Thayer, you were wrong. Look, here's my function, def nothing, and I returned it, and I call my function, and there's nothing here. So Professor Thayer, you were wrong. It didn't return because it didn't actually show anything, right? And when I run things interactively, it always prints them onto the screen. Well, if it's none, it's not going to. And I can force the issue by printing the function call to nothing, which now shows that it's none. The type can be showed by explicitly printing it to demonstrate to you that in fact it is returning none. So don't be fooled. It just gets suppressed because Python, again, is trying to be helpful for you, and I guess not wasting letters on your screen. It just chooses not to show the none because, well, I don't know why, because that's just how it works. And so we want to make sure that we are clear on this, that all functions do return something, just some functions return none, and the type of none is none type. So that can be a confusing point, but you need to just trust me a little bit on this. All right, so returning versus printing is another thing that continually causes students trouble. So a value that is returned from a function is available for further use within the program. It can be assigned to a variable, it can be used in an expression, and it can be passed as an argument to another function. This is known as composition. But a value that is only printed to the screen is lost to the program forever. So you have to remember, printing something on the screen just means changing the shapes, the colors of certain pixels on your screen in the shape of letters and numbers. That is not sharing information with your program. So let's compare these two functions. Here we have double return, And here we have double print. They both take some variable called n as an input parameter. This one is going to have the signature int to int, and this one has the signature int to none type. So this one is going to return double of n. So we have n times 2, very simple little program here. So if you send up 5, right, it's going to do n times 2, so that'll be 10, and it returns the value of 10. This one, on the other hand, does something different. It prints n times 2, so it's going to print the number 10 to your screen. This one returns something, which means that it could potentially be assigned to a variable, used in an expression, or passed as an argument. Whereas when we print this, this function returns none because it prints to the screen, which is causing a change in the environment, specifically on the screen, but it is not providing information back to the program itself. So this one has an implicit return and an implicit none here underneath, because this is presumably the end of the indentation here. So these functions have very different signatures because the mechanism by which they work is not the same. Generally speaking, we want to return things and not print them to the screen. So just to try to make this a little bit more clear, the print function causes the effect of showing the value on the screen. Ta-da, here it is on your computer screen. The print function does not return what is printed. The print function, in fact, returns none, because the print function's job is to change pixels and the shape. The function double print also returns none. So here we have double print, which prints n times 2. It accesses the computer hardware to cause the effect of showing the answer of n times 2 on the screen. That's what this print function does. And there is an implicit return none to the caller of this function, which for simplicity is not shown on this slide. So suppose you want to use the value that was returned by a function. So another thing that's very confusing to students who are just learning how to program. Returning the value alone is insufficient to be able to use it again. It's one of the things you have to do. It's one of those conditions, because you can't access it if you don't return it. But just because you've returned it doesn't mean it's actually been captured. It's like that Amazon box, if it gets delivered in nobody's home. Is there something in it or not? It's like if a tree falls in the forest, does it make a noise if nobody's there to hear it? Well, I don't know. So there always needs to be somebody there to receive that box in order to find out if there's something in it. Returning the value alone is insufficient. The value must be somehow captured. Capture the value in a variable, or you can capture the value by using composition. And so now we'll take a look at some of those different examples of how that could work. So here's a simple function called add that takes a and b. It can work with either integers or floats, and for either a and or b, and it will either return an integer or a float, and it sums a and b together. And we can see the local variable called answer takes a plus b and returns the answer. So suppose we want to capture the return value of add in a variable called a. So here we have a variable called a out in main equals, and here's our function call of add, and it's going to send up the values of 4 and 2. So a will be equal to 4 and b will be equal to 2. 4 plus 2 is 6, so answer will be 6. And we return answer to the caller, which is a equals. This right here is very important. This is the variable standing here, ready to grab that box when it comes out of the function. So a will get the value of whatever return answer sends, that is the 6. And now b equals a times 5. So now we can use the return value for a calculation. This is a pretty arbitrary calculation, but let's say you just need to multiply it by 5 for whatever reason. So b equals a times 5 will capture, so a captures the output of the function, and then b is equal to a times 5. So now you do 6 times 5 is 30, and now we can print method 1, and then the value of that, which will be 30, the final answer. But you could have done this another way. Here we're going to use the function composition with the functions call inside of a function. So the print function is, of course, a function. And so what this is going to do is it's going to print out method 2 and then add a 4, 2 times 5. So we've compacted all of this business down into just one line, which is fine to do. This may be more easy to follow, but this is also a way that it could be done. Now, again, this is like those orders of operation because we have this function call inside and we have some things to resolve. So first of all, we need to add a 4,2 to figure out what the answer that is, which of course is 30 because we just did that above. And then we have 30 times 5, just like you'd have in a math problem. So sorry, 4,2 will be 6, and 6 times 5 is 30. So now we have our 30 right here. And now we're going to print method 2 and we're going to get the 30. So we see that either way, we still get the 30. This is called composition because we had the function call embedded inside of the print, and we also had it times the 5 all together. So this is called composition, when you compose them all together into one thing and then you wrap it with the print. Whereas in this version, we took it and we broke it out into all of the different ones. So this illustrates that there's a couple of ways that we can capture the information that's getting sent out by the function. Either we can capture it in a variable, so A equals the result of add a 4,2 right here to capture A, and then we could figure out B and then finally print B, or we could do it like this. We could compose it all together to get the answer, that function, then we multiply it by 5 and put it directly into print. Either way will work, and either way is useful. If you do need to use the result A multiple times, this is the preferable way to do it because you have it in a variable. And so you can then use A again for another calculation if you need to do another calculation. But if you just have one composition or this way, either one is fine. So a few more things about composing the functions. Instead of storing the value returned by a function in a variable, it can instead be used directly as an argument to another function. That's called function composition, using the output return value of one function as the input argument to another. So we've just seen that, and here's another example. Double of x is going to return 2 times x. So here we're capturing it in a variable, y equals double of x, and then print y. Or you could simply just print the whole thing doing the execution of the function call right inside of print. Either one works. This is a spot the bugs activity for you to take a look at. So let's have a look at this. We have the concat of A comma B. And so this is going to have these signature 2 strings, and it's going to give back a string, and it's going to concatenate A and B. C equals A plus B, and then it returns C. So we want to write a function concat that will concatenate a string A and B to create a compound word, execute the function to concatenate these animal names. We have cottontail, kitty cat, and lionfish, and then we want to print that sentence, and then we're going to fill in the animal in that thing. And so here's some sample code produced by a fictitious student, produced by me, who knows what mistakes students might do. And let's see if we can understand what might be wrong. So when you see the bugs flying around on the code, you know that you should have your eye open to see if there's maybe something wrong with it. All right, so here's what the student did. They have a function call of concat of cotton, comma, tail. See the, and then concat run. So let's see if this is going to work. So we're going to concatenate, this is our function call. That looks pretty good. Cotton for A and tail for B. Okay, sounds good. And then we will, so there's the function call. So this will return cotton tail. But do you see that anything is captured? So you'll see that they're using this as a variable name. That's not right. This is the function call, and they've simply just plugged the name of the function here. That's not right. All right, let's look at another one. Concat of kitty plus cat. All right, so do you see that this will resolve to kitty cat right here? So when we make our function call of concat, we in fact only have 1 string, and this is looking for 2 strings. So this in fact will generate an error because there's an insufficient number of variables being supplied. Okay, now let's take a look at this one and see if they got this one right. See oh, there's the function call in the middle of this print. Oh, that means I need to pause the printing and I'm going to need to go and execute this. Concat of lion, comma, fish. All right, well, at least we've had enough variable values, right? So A will be lion and B will be fish. That looks good. C will be concatenation of A plus B, which will give us lionfish. So this returns lionfish as a compound word. So see the lionfish run. Okay, that will work. So then here is an example of how this could be done. Here are some print statements using the composition, because we have our function call inside, so you could do them all like this. You could also do this alternate solution where you are storing the value of executing the function into a variable called C. So return C and we're capturing it in C. This is illustrating shadowing. You could pick a different name for this. If you didn't want to do shadowing, that's fine. And then you'll do print C and now the C will be equal to the compound word run. And so we'll get cottontail, kitty cat, and lionfish all right here. All right, this is a great function that you're going to have the opportunity to work with later. What I want to point out in this function is that there are many function calls within the other functions. This is a great one to work on for tracing through what is going to call what, to draw your stack diagrams and to understand what the variables are going to be equal to. So we will see more of this coming up. I'll just call your attention to the idea that we have this calc area, which has a function call inside of a function. Here's another one that has a function call inside of a function. Finally, we'll get the area here. So you'll be tracing this all through to figure out where the pointer goes and also what the value of each of these is going to be. All right, well then I hope that this has helped you deal with some of those sticky points, some of those questions you may be having about the functions. We will see you next time for our final discussion on the functions. Thanks so much and see you later.